Marbles look simple at first glance, almost too simple to deserve a second thought. They are small, smooth, shining spheres of glass, the kind of object people roll across the floor, collect in jars, or remember from childhood games. But behind that tiny polished surface is a manufacturing story far more dramatic than most people imagine. Because many marbles do not begin as beautiful objects at all. They begin as broken glass, rejected bottles, sharp fragments, and discarded material that once seemed to have no future. What looks like trash on one side of the process becomes, on the other side, something round, colorful, durable, and strangely perfect. That transformation is not accidental. It is the result of heat, pressure, timing, recycling technology, mechanical precision, and a production line that must operate with almost no tolerance for mistakes. Think about the contrast for a moment. A cracked bottle is irregular. It has edges, labels, dirt, metal caps, and colors mixed without order. It belongs to the world of waste. A finished marble is the opposite. It is balanced, polished, controlled, and pleasing to the eye. It rolls smoothly because its shape is close to perfect. It catches the light because the glass inside has been melted, refined, colored, and shaped with care. Between those two states lies an industrial journey that is hidden from most people. Inside a modern marble factory, nothing happens randomly. Trucks arrive with mountains of used glass. Conveyors carry fragments through cleaning and sorting systems. Magnets pull away dangerous metal pieces. Optical sensors scan colors at incredible speed. Furnaces run day and night, pushing temperatures beyond 1,100 degrees Celsius until solid glass becomes a glowing liquid. Then, in a matter of seconds, that liquid is cut into hot drops, rolled by spiral mechanisms, and guided by physics into the shape of a sphere. It sounds almost magical, but it is really a carefully synchronized system. Every stage depends on the stage before it. If the glass is dirty, the furnace suffers. If the mixture is wrong, the marble weakens. If the cooling is too fast, the finished sphere can crack from the inside. Even an object as small as a marble demands discipline from an entire factory. So the next time you see one of these tiny glass balls, do not think of it as just a toy. Think of it as proof that waste can be recovered, reshaped, and given a new purpose. From sharp fragments to perfect spheres, the story of a marble is really the story of transformation. The journey begins far away from the marble factory, in places where glass seems to have reached the end of its usefulness. Empty bottles are left in homes, restaurants, supermarkets, recycling bins, and return machines. To most people, they are just containers that have already served their purpose. But for the recycling system, every bottle is still a valuable raw material waiting to be recovered. In many collection systems, the first step is surprisingly precise. Bottles are fed into return machines that do more than simply accept waste. Sensors examine each item in seconds, checking its shape, size, material, and sometimes its color. If the bottle matches the required criteria, the machine accepts it, stores it, and gives the user a small reward. That reward may look minor, but it encourages a steady flow of glass back into the industrial cycle. One person returns a few bottles. A supermarket collects thousands. Across a city, that becomes tons of reusable material moving every day. Once collected, the bottles are compacted and transported in bulk. Large trucks follow regular routes, carrying loads of used glass toward recycling plants. At this stage, the material has not yet become anything new, but its identity has already changed. It is no longer only waste. It is feedstock. It is the beginning of another product. Glass has a major advantage here because it can be recycled repeatedly without losing its essential quality. Unlike some materials that degrade after each cycle, properly processed glass can return again and again to the furnace. When the bottles arrive at the recycling plant, the real preparation begins. This is one of the most important stages because marble production depends on clean, consistent glass. A factory cannot simply throw dirty bottles into a furnace and hope for the best. Dust, labels, plastic rings, metal caps, ceramics, stones, or food residue can all create problems later. Even a tiny impurity can affect the way molten glass behaves, damage equipment, or weaken the finished marble. The first cleaning stage usually starts with large vibrating conveyors. As the glass moves forward, the vibration shakes loose dirt, dust, and small surface particles. The motion looks rough, but it has a clear purpose: to remove anything that does not belong before the material reaches more sensitive systems. Workers may also supervise the stream directly, pulling away obvious contaminants such as plastic pieces, labels, or unusual objects that machines might not immediately remove. Then stronger separation technology takes over. Industrial magnets are used to remove metal fragments, including caps, rings, wires, and tiny pieces that may have become mixed with the glass. This step is critical because metal should never enter the furnace with the glass batch. It can interfere with melting, contaminate the material, or cause mechanical damage. For that reason, the plant treats cleaning as a matter of protection as much as preparation. By the end of this phase, the bottles have lost their original identity. They are no longer recognizable as drink containers from a store shelf or a kitchen table. They have been gathered, rewarded, transported, shaken, inspected, and stripped of obvious contamination. What remains is not yet ready to become a marble, but it is ready for the next and more destructive step: crushing. Before glass can be reborn as a smooth sphere, its old form must first be completely broken apart. After the first cleaning stage, the glass is still not ready for the furnace. It may be cleaner than before, but it still carries the shape of its past life. Bottles have curves, thick bases, thin walls, broken necks, and uneven surfaces. None of that is useful for the next phase. To become efficient industrial material, the glass must be reduced to something smaller, more uniform, and easier to melt. That is why the bottles are sent into powerful crushing machines. Inside these machines, steel hammers and heavy rotating mechanisms strike the glass again and again at high speed. The sound is harsh, and the action is violent. Whole bottles disappear almost instantly, breaking into thousands of sharp, irregular, shining fragments. What was once a clear container now becomes a chaotic mass of pieces known as cullet. This destruction is not wasteful. It is one of the reasons recycled glass is so valuable. Cullet has already been through a furnace in its previous life, so it generally melts more efficiently than raw mineral materials alone. Smaller pieces expose more surface area to heat, allowing the furnace to work with less energy and greater consistency. In large-scale production, that matters enormously. A small energy saving repeated across tons of glass can become a major advantage for cost, speed, and environmental impact. But crushed glass also creates a new problem. Once everything has been broken apart, different colors and compositions can become mixed together. Clear fragments may sit beside green glass, brown glass, blue glass, ceramic bits, stones, or other unwanted materials. If this mixture is not controlled, the final product can suffer. The color may become muddy. The transparency may change. The strength and behavior of the molten glass may become unpredictable. To solve this, the cullet moves onto high-speed sorting lines. This is one of the most impressive parts of the recycling process because it combines speed with extreme accuracy. As the fragments travel along conveyors, industrial cameras and optical sensors scan them one by one. The system detects color, brightness, shape, and sometimes chemical or material differences. In fractions of a second, compressed air jets fire at exactly the right moment, pushing selected fragments into separate channels. The process happens so quickly that the human eye can barely follow it. Thousands of small pieces move every minute, yet the system keeps dividing them into cleaner, more useful streams. Clear glass goes one way, colored glass goes another. Contaminants are rejected. What began as a mixed pile of broken waste becomes a controlled industrial ingredient. Only after this sorting stage can the factory begin preparing the glass batch. The cullet is combined with essential raw materials such as silica sand, soda ash, and limestone. Each ingredient has a purpose. Silica forms the basic structure of the glass. Soda ash helps lower the melting temperature, making the process more manageable. Limestone improves stability and durability, helping the finished glass resist damage and hold its form. The proportions must be calculated carefully. Too much or too little of one component can affect transparency, hardness, melting behavior, and the way the glass performs when it is shaped into marbles. In a factory producing huge volumes, consistency is everything. The batch must enter the furnace with the right balance every time. At this point, the material has passed through collection, cleaning, crushing, sorting, and precise mixing. It no longer resembles the discarded bottles that entered the system. It has become a prepared recipe for transformation. The next step is the most extreme stage of all. Heat so intense that solid fragments lose their boundaries and become a glowing liquid. Now the prepared batch is ready for the furnace, the place where the most dramatic change in the entire process takes place. Until this moment, the material has been handled, cleaned, crushed, sorted, and measured. It is still solid. It still has edges, grains, and fragments. But once it begins entering the melting system, all of that disappears. Modern glass furnaces are built for continuous operation. They do not work like a small oven that is turned on for one batch and then shut down. In large factories, the furnace can run day and night, feeding, melting, and releasing glass without interruption. This constant rhythm is necessary because temperature stability is one of the keys to quality. If the heat rises or falls too much, the behavior of the molten glass can change, and that can affect every marble produced afterward. Inside the furnace, the temperature rises beyond 1,100 degrees Celsius. At that level, the glass batch begins to soften, collapse, and fuse. The sharp fragments lose their edges. The sand and minerals become part of the same glowing mass. What once looked like separate pieces slowly turns into a thick, incandescent liquid. It is bright, heavy, and dangerous, moving with a slow power that only extreme heat can create. The environment around this stage is just as intense as the process itself. Heat radiates from the furnace and spreads into the surrounding work area. Operators must use specialized protection because even standing near the equipment can be demanding. Yet the line cannot stop. The furnace must continue feeding the production system with a steady flow of molten glass, and every movement has to remain controlled. At the bottom of the furnace, the liquid glass exits through a carefully regulated opening. This is not a random spill. The flow is adjusted so that the right amount of material comes out at the right speed. Too much glass would create oversized drops. Too little would produce weak or incomplete pieces. The balance between temperature, viscosity, pressure, and flow rate determines whether the next stage can work properly. Just below the outlet, mechanical blades begin their task. They move quickly, opening and closing in perfect rhythm. Each cut separates the stream of molten glass into small, glowing portions. These portions are often called gobs, and they are the first real step toward individual marbles. At this moment, they are not beautiful, they are not polished, they are not even round. They are soft, unstable drops of hot glass, still carrying the energy of the furnace. Timing is everything. If the blades cut too slowly, the gobs become too large. If they cut too quickly, the pieces may be too small or irregular. The machinery must match the speed of the glass flow exactly, because hundreds or even thousands of marbles may depend on that rhythm every minute. A tiny difference repeated over and over can create major waste. Once cut, the glowing drops are guided away from the furnace while they are still soft enough to be shaped. They must move quickly but not chaotically. The goal is to preserve heat long enough for forming, while also keeping each portion separate and controlled. This is the moment when molten glass leaves behind the world of liquid movement and enters the world of mechanical shaping. The sphere has not appeared yet, but the conditions for it have finally been created. The glowing drops leaving the furnace now enter one of the most fascinating stages of marble production. They are hot, soft, and unstable, but they contain everything needed to become perfect spheres. At this point, the factory does not force the glass into round molds. Instead, it uses motion, gravity, and the natural behavior of molten material. Each hot gob is guided onto a system of rotating spiral rollers. These rollers are positioned so the glass cannot simply slide forward. It must roll. As the rollers turn, every drop moves along the channel while spinning continuously. The movement is constant, forward, around, forward again. With each rotation, the material spreads more evenly through itself. Thick areas soften, uneven edges collapse. The surface begins to smooth. The most important force working here is surface tension. When glass is hot enough to move but not so liquid that it loses control, it naturally tries to pull itself into the most stable shape possible. That shape is a sphere. The spiral rollers keep the glass moving long enough for this force to do its work. In only a few seconds, what began as an irregular glowing drop starts to become a round marble. This stage looks simple from the outside, but it demands exact timing. If the glass is too hot, the sphere can deform. If it is too cool, the surface may not smooth correctly. If the rollers move at the wrong speed, the marble may become uneven or stretched. The factory must control temperature, rotation, spacing, and movement all at once. When everything is balanced, thousands of spheres can form continuously, one after another, without stopping. But shape is only part of the story. A marble also needs identity. While the glass is still hot and workable, color is introduced into the process. Factories use carefully measured metal oxides and colored glass additives to create different tones. Iron compounds may help produce green shades. Cobalt can create deep blue. Other materials can produce amber, milky white, dark smoky tones, or bright decorative effects. The exact recipes vary depending on the design being made. The goal is not always to mix the color completely. In many marbles, the beauty comes from partial blending. Colored streams, ribbons, or small portions of glass are introduced so they move through the transparent body without disappearing into it. As the marble rolls, these colors stretch and twist inside the sphere. They become lines, veins, swirls, clouds, and layered effects. Light later passes through these patterns and makes the marble appear deeper than its small size suggests. This is why mass-produced marbles can still look surprisingly individual. The machines follow a controlled process, but tiny variations occur in heat, flow, rotation, and color distribution. One marble may show a sharp spiral, another may contain a soft internal wave. Another may trap a bright streak near its center. The same production line can create thousands of similar pieces, yet small differences make many of them feel unique. For more complex designs, some factories may add extra colored elements at specific points, giving certain marbles stronger decorative patterns. The result is a balance between industrial precision and natural variation. Machines create the roundness, chemistry creates the color, motion creates the pattern. And in a few brief seconds, a glowing drop of recycled glass becomes something recognizable, a marble with shape, color, and character. After the marbles have gained their round shape and their internal color patterns, they still are not finished. In fact, they are at one of their most delicate moments. The glass may look solid from the outside, but it still holds extreme heat inside. If these newly formed spheres were dropped into a cold environment too quickly, the surface would contract faster than the center. That difference would create internal stress, and a marble that looked perfect could later crack, split, or break without warning. For that reason, cooling is not rushed. The hot marbles are directed into heat-resistant metal containers or controlled cooling systems, where the temperature falls gradually. This stage can take hours, and in some cases it may last nearly a full day. The purpose is to let the entire sphere stabilize evenly, from the outer surface to the core. In glassmaking, time is not an enemy. At this point, time is protection. Once the marbles have reached a safe temperature, inspection begins. Workers and automated systems check the batches for size, shape, surface flaws, cracks, bubbles, and irregular patterns that do not meet the required standard. The process may be highly automated, but quality control still matters. A marble must roll properly, feel smooth, and survive handling. Pieces that fail inspection are not simply wasted. Because glass can return to the cycle, rejected material can often be crushed and melted again. The accepted marbles then move toward packing stations. Large quantities are weighed with care because each bag, sack, or container must meet a specific amount. Too little would fail the order. Too much would create unnecessary loss. After weighing, the packages are sealed securely so the marbles can travel without spilling or being damaged. What began as discarded bottles and broken fragments is now ready for stores, games, collectors, and factories that use small glass spheres for other purposes. Yet beside this massive industrial process, there is another world of marble making that feels almost opposite: the handmade method. In that version, an artisan gathers molten glass on the end of a metal rod, turning it carefully in the heat. Colored fragments are added by hand. Layers are built slowly. The glass is reheated, rolled, shaped, and guided with simple tools and trained movements. There are no high-speed optical sorters or synchronized cutting blades correcting every detail. The craft depends on human timing, patience, and instinct. A handmade marble may take far longer to create than a factory-made one, but that is part of its value. Each piece carries the trace of the person who shaped it. No two are truly identical. In a world where machines can produce millions of glass spheres with astonishing speed, the handmade marble reminds us that beauty can also come from slowness and intention. In the end, a marble is more than a small glass ball. It is the result of collection, cleaning, crushing, sorting, melting, shaping, coloring, cooling, inspection, and sometimes human artistry. It proves that discarded material can be transformed into something useful, beautiful, and lasting. What once seemed useless can return with a new form, a new purpose, and a quiet kind of perfection.